A warm and hearty welcome to all the esteemed participants, respected resource person, and faculty members to the Day 2 of Faculty Development Program organized by School of Science of KSR College of Arts and Science for Women. We are thrilled to have you here and look forward to insightful discussions, knowledge sharing, and networking opportunities. Let's make today a memorable and enriching experience together. I now welcome M.Sc Gunachitra, Assistant Professor, Department of Physics, to deliver a welcome address and chief case profile.
Good afternoon to all distinguished guests, faculty members, research scholars, and attendees. With the blessings of our late founder, Lion Dr. K.S. Rangasamy, MJF, and our Lord, it is a pleasure to welcome you to today's special session on collaboration that inspires academic growth and interdisciplinary progress in our institution. I am honored to welcome our endearing chairman of KSR Education Institutions, Mr. R. Srinivasan. I am also feel privileged to welcome our charismatic Vice Chairman, Mr. S. Sachin, and our meritorious Executive Director, Mrs. Kavita Srinivasan, in absentia. With great respect and joy, I extend a warm welcome to our exceptional administrator, the visionary leader, our principal, Dr. M. Karthikeyan. We are grateful for your vision and leadership. Today, we feel privileged to host an eminent scientist and educator whose achievements have set benchmarks in the field of chemistry. Let us extend a warm welcome and our gratitude to our distinguished guest. It is my honor to introduce Dr. Pachamuthu, M.Sc MPhil, PhD, Assistant Professor in Chemistry at Institute of SRM Institute of Science and Technology, Trichy campus. Dr. Pachamuthu specializes in nanostructured materials, metal oxides, photocatalysis, and environmental chemistry. He completed his PhD at Anna University, Chennai, and has earned degrees from esteemed institutions such as Madurai Kamarajar University, National College, Bharadasan University, and Bishop Gibbard College. With extensive research in areas like water treatment, catalysis, and solar energy conversion, Dr. Pachamuthu has contributed over 57 peer-reviewed articles and has presented at numerous national and international conferences. He has successfully guided PhD students, served as a guest editor, and continuous active collaboration with the global researchers. Dr. Pachamuthu's prolific research and dedication to mentorship have earned him recognition in the scientific community. We are delighted to have him with us today and look forward to his insights.
Thank you, Gunachitra. We are delighted to have your session, sir. The session is yours, sir.
Yes. Am I audible? Hello?
Yes,
Am I audible?
Yes, sir.
Okay, fine.
Yes, sir, audible.
Okay, sir. So my slides are visible?
Yes, sir. Visible.
Visible, sir.
Okay. So is it moving?
No, sir.
Is it not moving?
No, sir.
How is it moving?
Yes, sir. It is moving now.
Okay, madam. Thank you, madam. So so it's almost 2 o'clock. So generally after lunchtime, it's too hard to listen any lecture. Okay, anyway, I will try to give you some brief outline about this topic, like atoms to algorithm, the convergence of nano engineering and AI. So first of all, I would like to thank KSR College of Arts and Science for Women, Tiruchengood Namakkal, for inviting me this FDP program. And uh, Department of Physics, HOD Babu sir, I must thank him for inviting this seminar. So okay, so let's move on to the topic. So here, I hope you know that this is a so overall it's a big area of research topic, actually nano engineering and AI. Uh, so in this 30 to 40 minutes, I'm going to give you some glimpses of what are the area of research going on and what are the topics which we can do. Like that, I will tell you some brief glimpses on the topics. So first, I hope you know that. So we are in the era of AI, artificial intelligence. Wherever we go, the word is hearing in our ears, like AI, machine learning, deep learning, CNN, whatever. But the thing is, so our generation, that is X and Y generation, and our students, like generation Z, millennial students, they are going to face the world that too AI based world. So they are the AI, that is artificial intelligence or machine learning, are the competitor for them. So we must train them. So we are in the position to train the students. So how they will survive in this society for the upcoming generations. Okay, so this is a overall outline we're going to discuss. So what is the basics of nano engineering, some basic topics, and what are the algorithms involved in the nanomaterial preparation or some characterization, whatever, are the second part. And third part, how this kind of nanomaterials and machine learning topic, and finally applications where it is, these two topics are where it is applied. So that's a some glimpses we are going to see in this upcoming 30 to 40 minutes. Okay, so why we need to see a nano engineering? Because nano engineering, I hope we all know that. So today, this nano engineering, it's a ruling in our many industries, or many industry, or many different areas of research, like electronics, medicine, healthcare, material science, energy and environment, and consumer products. Let's take electronics. Nowadays, we are using many computers and smartphones. So all these are mainly so in somewhere these kind of nano materials are used in it. And next one, medicine and healthcare. So that kind of drug delivery systems and tissue engineering. There are a broad area of research. So material science. Next, third is material science and energy environment, solar cell, batteries. So these are the some of the areas. Uh, the nano engineering applications are mainly involved in it. And not only that, this is restricted. There are many areas are there. So generally, nanotechnology, I hope we all know that nanotechnology and nano engineering is an interdisciplinary research. Like, so chemistry people, I can do, physics people, or engineering people, or biology people. So science, and it's a combination of science and engineering or technology, right? Okay, this is a timeline, or a period of timeline, how these nanomaterials are developed from the beginning. So, so in the year of 1857, the gold colloid suspensions are fabricated, right? And after that, so after a period of time, you can see here there are certain years, right? In 1935, 52, that's carbon nanotubes are observed. And once a famous scientist called Richard Feynman, he he's the only one, he's the first person to give the lecture on the topic called there is a plenty of room at the bottom. So that's why he called as a father of nanotechnology. So after that, so over a period of time, you can see there are many developments are there in carbon nanomaterial preparation and applications. These are the over year by year that's it's developed. So almost we are in the year of almost 2025. So it's a almost 6 decades of after that materials are known to that world. But not only that, so there are many evaluation or many applications are there. The many research are keep on going on it. Okay, so nanotechnology. So some basics. I hope you know that. So nanotechnology is anyway it's our research and development area, but it's not a new to us. So nature and nanotechnology. I hope you can see this image, beautiful images. You can take colors and web and reptile legs and you can see the final one. The leaves, lotus leaves, right? Non-stick leaves. So for all these are here, mainly that's because of nanomaterials. Somewhere the nanomaterials are there in some part of the uh, colors or some this kind of materials, right? So okay, so everywhere is a nanomaterial is not a new to us. It's already there in our nature. I will give you some couple of example. So one more example you can see here. It's a 4th century cup. It is there. It's called a Lycurgus cup. The beauty of this cup is when you see this, when you pass the light on this cup, it's almost a 4th century cup. So Lycurgus is a king. He used that cup for somewhere. What is the purpose? If you don't know, but okay. So it is still there in a British museum. When you pass the light on the surface of the cup, you can see a green color. Whereas if you pass the light inside out, you can see a red color. So that's the beauty of this cup. So once the scientists have examined what kind of material it is there, so they found this is a combination of silver and gold clusters. It is there. So the the how fabrication of nanomaterials in the nano form, it was there in that time itself. That's the 4th century. So how it looks like, you can see the one more example. So that's because generally we all know that uh, gold is generally in yellow color, right? Or okay, shiny yellow. So when you convert that into a nano size, right, you can see a different colors, varieties of colors that depends on the size and shape of the gold. And not only that, if you convert the silver into nano size and different shapes, you can see a spherical shape, triangle, rod. So it will show you different colors. That's the beauty of nano materials. When you go to the big size to small size, the total, the properties here, it is changing. And you can see the another example, uh, only single gold that we can convert it into a sphere shape, shell, nano rod, cluster shape, nano cage, and nano star. So these are the possible different shapes and size we can make with the help of this nanotechnology. So it's a atom by atom building of object, right? A nano size, nano sized and nano shaped object. Okay, then you can see here, this is only, it's composed of zinc oxide, only zinc oxide material, but you can see a varieties of size and shapes. So almost 17 different shapes are there here. Uh, so it's only a combination is only zinc oxide. So that's the beauty of nanomaterial. You can prepare different size, different shapes, right, with different synthesis methods. We used to follow many synthesis methods. I will show you one by one. So these are the beauty of the nanotechnology, how we can prepare or how we can shape on the material. So there are many combination of nanomaterials are available, like pure metals, it is available. We can synthesize metal oxides, we can synthesize metals and metal oxides, we can prepare metal oxide combinations and mixed metal oxide combination, metals plus non-metal combination, core shell and carbon material supported pure metal and metal organic framework, and finally M.Sc. So I will show you some example. So these are the mainly solid based nanomaterials and with different combinations that we can, it's already there. There are many reports are there how to prepare this kind of materials. I hope you know all know that. Next one is a carbon-based material. Again, it comes under nanomaterial category. Diamond and fullerene, carbon nanotubes, graphite, graphene, graphene oxide, carbon dots, and these are the different materials which is composed of mainly carbon, right? And not only that, this kind of carbon-based material will show you uh, different properties compared with um, copper and pure silicon. So high melting point, thermal conductivity, density, mobility, right? So that's why we are using it nowadays for many applications. Okay. So is it new to us? Not really. Actually, I hope you know that in Keeladi excavation, they found some pot, right? Broken pot. In that pot, if you see that a black color, it's nothing but carbon nanotubes. So the thing is, so almost 3,000 or 4,000 years before, they know how to prepare this kind of nanomaterials, right? And one more recent development in this material research is amexine based material. There are many combinations of amexine with the titanium, zirconium, hafnium. Because of this high electronic property, hydrophobic property, many properties are there. So almost 30 new compositions are there in MXC based materials. Okay, come to the preparation for whatever may be the nanomaterials. These are the two major methods we can prepare, like nano fabrication methods. One is top down method and one is bottom up approach. So it's a known example, like if you take a laddu, right? So when you break the laddu, right, it will end up with bundi, right? So bundi we can consider as atom. So it's a kind of top down method, right? If you add this small size of bundi and make it into a laddu, big size or small size, that is called bottom up approach. So these are the two major method we can prepare any kind of nanomaterials. So I will show you some chart on it. So nanomaterial synthesis mainly a top-down and bottom-up approach. So here mostly top-down approaches are physical methods, right? You can breaking into a small nano-sized materials. So example lithography, PVD method, and ball milling method. These are the comes under physical method, and bottom-up approach mostly are chemical methods and biological methods. I will show you one couple of example for each methods. Um, Chemical methods such as sol gel, CVD method, co-precipitation, hydrothermal. So these are the methods comes under chemical methods, and biological method generally used to plant extracts and enzymes, agricultural waste. So these are the methods. So far, there are many scientists. They have been working on it to prepare a nanomaterials all over the world. So this is a chemical method. We can use some autoclaves or oven, right? CVD method. Okay, so a microwave oven. So we can prepare this kind of nanomaterials with the help of this small instruments or small apparatus. So this comes under salt gel and chemical deposition method, hydrothermal method. This is called chemical methods. We can use some chemicals as a stabilizing agent or capping agent or whatever. Then microwaves in this method, we can prepare, there's a combination of tin oxide and zinc oxide nanocomposites we can prepare. And we can support, right, graphene oxide, and we can support copper oxide material, nanocomposite we can prepare. And so one of the beauty, one of the beauty in the nanomaterial synthesis, metallic nanoparticle synthesis by using biological method, or we can simply call it as a green synthesis methods, because we all know that India is rich in biodiversity, right? So we can see many plant and many leaves or trees leaves, or there are many plant-based materials are available in our India. So we can use it for nanoparticle or nanomaterial synthesis. So you can use a plant source like leaves, roots, flower, fruit as a capping or stabilizing agent, and microorganisms like bacteria, fungus, algae we can use for nanoparticle synthesis. This comes under green synthesis methods. So if you just Google it, or you will get a uh, so there are millions of papers in it, green synthesis of nanoparticles, right? So that it indicates all over the world there are many scientists or mainly nanotechnologists are working on this kind of green synthesis methods. So that's a very easy method. So you can see so you can use yeast, fungi, bacteria, microorganisms you can use for nanoparticle synthesis, and plant-based you can use it for nanoparticle synthesis. From what is the use of this kind of nanoparticles? You can see the applications. You can use it as an antimicrobial and anti-pathogenic agent, for cosmetic application, medical applications, and in some magnetic various type of human cancers. So these are possible with this kind of plant-based nanoparticle synthesis. So one more a well-known example is, we all know that Siddhars, right? So Siddhars, uh, they prepared some kind of nanomaterials in the ancient days. They have prepared many metal-based nano-sized metals or alloys, right? So there are many examples are there. If you take Bogar, right? So in Palani, it's a Bogar. So he made a statue, right? Murugar statue, right? So it's a purely Navapashan சொல்லுவாங்க இல்லையா? So fine. So this that one mainly using with the help of some plant extract. So that's a beauty. And not only that, I will show you some examples how we can convert on a one metal to another metal, or one element to another element with the help of plant-based sources. And not only that, I hope you know that the குறள் சொல்லுவாங்க இல்லையா? அணுவை துளைத்து ஆழ்கடல் புகுத்தி குறுக தரித்ததோர் குறள் அப்படி சொல்லுவாங்க இல்லையா? ஸோ தட் அந்த 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 வேர்ட்ஸ் பார்த்தீங்க அப்படின்னா, ஸோ அணுவை பிளந்து அப்படிங்கிறது, ஸோ that word is to break the atom. It is first it is announced by that kind of siddhars, right? So in the world, so before that no one knows, right? So breaking of atomங்கிறது நம்ம in previous it was not there, right? So this kind of siddhars, they are making this different kinds of alloys or metal based, right, with using this kind of so see the one such example. இப்போ so one famous book is called மருந்தாக்கிதப்பா மர இன பட்டைகள் சொல்லிட்டு அந்த புக்ல பாத்தீங்க அப்படின்னா, இப்போ நார்மலி கேன் வி கன்வெர்ட் some some other elements into gold அப்படின்னா, it is not possible right now. But you can see we can convert with the help of suitable plant based material அப்படிங்கிறது it is there. So you can see ஈயத்தை பற்பமாக்கி, it's in Tamil. So செம்பை பற்பமாக்கி, தங்கத்தை பற்பமாக்கி, and இரும்பு அருப்பி, அயம் உருக்கி, அயத்தை ஈயமாக்கி, right? So ayam is nothing but iron, right? Iron. ஈயம் அப்படிங்கிறது lead, right? So iron, so one, it is converted into one into another one. So it's all, it is there with the help of this kind of small plant, right? செடின்னு சொல்லுவோம். செடி, so you can see here கீரை வகை and மூலிகைகள், right? So all these are possible with this kind of plant-based origins. So we can prepare nanomaterials with this kind of plant. So some other example you can see. So using mango leaf extract, you can prepare silver nanoparticle. Aloe vera extract, you can prepare silver nanoparticles. You just simply mix it these two at particular condition, right? Temperature and uh, time, right? You will get a nanoparticle. So it's a conversion of silver plus to silver 0. And using that, we can sense mercury in the water And not only there are many applications. So almost all the plant or all the leaf extract or all the root and fruit extract. So we can use it for nanoparticle synthesis. So and one more example, so it's a plant we can prepare a silver nanoparticle and use that for anti thrombolytic studies. As an example, and so this kind of flower we can crush it and that we can use that juice for making silver nanoparticle, and from that silver nanoparticle you can use it for dye degradation and antioxidant studies. There are many results are there, many publications are there in that area. Fruit waste plus fruit waste based silver nanoparticle preparation with the different sizes and different shapes you can prepare, like rod shape, flower shape, right? That is possible with this kind of fruit waste. I mean the fruit juice or the pomegranate cover extract, right? And not only that, நம்ம நுங்கு இருக்கு இல்லையா, it's a palm tree fruit, right? From that we can prepare silver nanoparticle, the gel இருக்கு இல்லையா, from that gel we can prepare silver nanoparticle and gold nanoparticle. Using that we can reduce the dyes, and there are many applications are there. Anti-cancer studies. So this is some of the examples I'll show you. And not only that, so waste we can bio waste, like banana flour இருக்கு இல்லையா, அந்த banana flour waste இருக்கு, அதுல இருந்து we are preparing some silver nanoparticle. அதோட extract எடுத்து juice, then we can prepare a silver nanoparticle and use that nanoparticles for anti-thrombolytic study, antimicrobial study, and antioxidant studies. So this is exactly mimicking the nature, right, for our chemical synthesis using that plant extract. And fruit extract, that also we can use it for copper nanoparticle synthesis. So different fruits like orange, then amla, right? So we can use it on this kind of fruits and we can prepare. And one more, so we have filed a patent in it. From the கிழங்கு இருக்குல்ல, முடவட்டுக்கால் கிழங்குன்னு சொல்லுவாங்க, it's commonly available. So from that we are preparing some gel and making the gel for medicinal applications. We are converting that as a gel, and that is used for some kind of arthritics, curing the arthritics, rheumatic arthritics. And also we mixed up with this kind of gel and silver nanoparticle. So so these are the some of the results derived on it. And the second part is microbial synthesis. So using some microbes we can prepare many nanoparticles. So using bacteria, fungi, algae, yeast, virus we can prepare. And not only that, we can use it, the bio waste, right, as a carbon source to disperse the nanomaterial. Here you can see a coconut shell and a groundnut shell waste இருக்கு இல்லையா? So simply we can convert it as a carbon material or carbon support. So we can use that kind of carbon source for dye removal or some other heavy metal removal. So that's all possible. Okay, so this kind of nanoparticles or nanomaterials are used in many areas that we discussed before, like semiconductors, electronics, packaging, sensors, cosmetics, automobiles, like catalysis, paints. There are not only that, there are many are there. There are many applications are there. Okay, you can see the importance, how it is important in the global market, nanomaterial market size. You can see here. So, so it is in the so mainly in 2030, you can see the global nanomaterial market value. It is in the USD billion values. So almost you can see so slowly are increasing. Mainly these are the area which the nanomaterials is used is medicinal field, electronics, and paints and coatings, energy power, aerospace, automobile, and other appliances. So you can see the dark, right? So the dark one is the mainly some medicinal field. Then these kind of nanomaterials are going to used in this medicinal field, and next to that electronics, and next to that paintings and coatings. So these are the three major area this kind of nanomaterials are going to use. Uh, and you can see the some of the nanomaterials mainly it is there in the market like gold, silver, iron, platinum, titanium, and other materials. And mainly again that will be used in medical and energy, power source, electronics, and aerospace applications. And these are the key players in the market. Companies like Stream, American Elements, US Research Nanomaterials, Nano Composites, Nanoshells. These are the companies they are uh, preparing or synthesizing these different nanomaterials, and they are selling it in the market. Okay, so that's all about the basics of nanomaterials and that one. So next we move on to the AI based topic. So how these kind of nanomaterials or nanoparticles are coupled with this kind of machine learning or AI based topic. So I hope you know that in every day we are using different kinds of machine learning based sources, right? If you take emails, again it's a basic is machine learning, and YouTube, right? When you scroll down the some songs or whatever, uh, it suggests, right? So in the near to that, it will suggest some okay recommended, right? It will give you some recommendation. So based on your previous search, right? And not only that, our Google Assistant, Apple Siri. This is a mainly a natural language processing based one. And not only that, navigation system, communication. When you type, it will show you some full content, full message, right? Again, it's a basic is machine learning. And mobile banking apps and smart home devices, healthcare. So all these are it's there in our daily life, right? AI. Okay, so one more example, it's you can see here. So it's a magic of AI, right? So this is a picture. So if already uh, it is there, it was there in many newspapers that time. Kumbh Mela நடந்துச்சு இல்லையா, that time. Actually, these famous persons they were not there in that time. I mean, they have not attended that Kumbh Mela, but in using that AI they have created, right? So, but the thing is, whatever it is not there, we can create. I will show you some one more video. Sir, is it visible? Hello, sir. Is it visible or
Yes, sir, it's visible, sir. You're audible
no?
too.
The
Yes, sir. Yes, sir. Yes,
videos
sir.
is visible.
Sir, the video is not visible, sir.
Okay, madam. Okay, madam.
The video is not playing.
Just a minute, please. Now, madam, is it visible?
Yes,
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 sir.
yes.
Sir, it is visible,
Okay.
sir.
Yes, yes, yes.
It's playing, sir.
Yes. Yes. The thing is, I hope you enjoyed the video. Actually, Abdul Kalam sir and Ratan Tata, Charlie Chaplin, Mr. Bean. So they were in the different time periods, right? So with the help of this AI, and it is possible, right? Okay, so how this kind of nanotechnology and machine learning or AI is coupled. So with the help of this machine learning, we can synthesize or design the nanomaterials. That's the thing, and we can do a characteristics of that particular material. Whatever the nanomaterial we prepared, with the help of machine learning, we can predict that characteristics properties of that material, and we can optimize the structure of that material. I will show you one example of each. And synthesis route we can design with the help of this machine learning approach. And not only that, we can do some spectroscopic analysis, data analysis, that is called data visualization, that we can do, like spectroscopic analysis, the data like IR and UV. Using that data, we can do some clustering algorithms, or you can split the data. So, and image processing, I will show you one by one examples. So artificial intelligence nanomaterials, right? So this is a tree. You can see machine learning is a part of artificial intelligence, and in that part, machine learning, there are many subcategory are there. Mainly chemometrics. That is called chemometrics. It's a using a chemical data. You can process that data with the help of different algorithms. You can get a result, right? So that's a topic called chemometrics. Okay, so why we should go for a machine learning based technique for nanomaterial synthesis or nanomaterial property studies or nanomaterial applications? Because as we all know that generally nanomaterial is having high surface to volume ratio, and not only that, it will show you different property. It depends on the structure and depends on the size and shape. So normally our traditional experimental methods and theoretical stimulation, it is not up to the mark to predict the nanomaterial properties. So machine learning based approach, generally it is more effective, and it will also leads to develop new materials, also new material, not only new materials, and design the materials also. It is possible with the help of machine learning approaches. So there are many machine learning algorithms are there. So these are the most uh, mostly used algorithm, like KNN, nearest neighbor, K means decision, SVM. These are many are there. Not only that, so this is a timeline you could see here. So this kind of machine learning and how these two are merged, right? Nanomaterial in one side, and another side is this kind of algorithms, development of algorithms, starting from PCA, principal component analysis, and at one stage around 2010, you can see here. So these two lines, parallel lines, it right, it's mixed in one that year, right, 2010. So here from that 2010, uh, so the scientists, they have merged these two areas, like nanoparticles or nanotechnology with this kind of AI or machine learning techniques. So after that, so almost it is 2010. So almost 15 years. There are many developments are there with nanotechnology with this kind of machine learning or AI approach. I will show you some examples. So these are the many algorithms are used so far, used in our search purpose. Machine learning approach, mainly it comes under supervised learning based algorithms. unsupervised learning algorithms. So these are some of the examples, and not only that, there are many are there. So so these are the algorithms. So far it was used for nanomaterial synthesis purpose or characterization purpose or application purpose. So one such example you could see here. So how we can apply this machine learning for nanomaterial development? You can see the workflow. So it's almost different steps involved in it. First, step 1, step 2, step 3, like almost 7 steps are there. So generally the first step is collection of data, and selection and extraction of data, and third, data splitting. So it's mainly handling of data. So generally, I hope you all know that. So machine learning, it can handle a huge set of data. Uh, you can give a enormous amount of data, it will handle it, and it will frame a set of rules, right? That is called algorithm. We can develop different algorithms also. That's a part of computer science and max people's work, but we can use it, that kind of different algorithms for different purposes. So this thing you can see here, materials design with the machine learning approach. You can see. So generally, uh, it's a different stage wise process. Synthesis, characterization, and catalytic test in our lab, that is converted into database and literature and human intuition. And the third one is computer screening, and finally it goes to the ML prediction, machine learning prediction. So it's a stepwise process. So simply it's a narrow down the total work. You can see you can get a huge number of datas. So whatever may be your synthesis or the property of the material or application of the material. So it's creating a huge set of data base, and that database is again narrowed down into computational screening, and again it's narrow down, and at the end you can see it's purely experimental validation. You can use it. So with the help of this kind of machine learning, we can develop the future materials, right? So generally, this kind of ML is used in material property prediction, structure optimization, and synthesis pathway design. So instead of going complicated synthesis route, with the help of data set or with the help of machine learning, you can narrow down or you can simplify the synthesis route. So you can see the one example with the help of crystal structure determination. So almost 706 AB compounds, that is uh, crystal structures are there. You can see sodium chloride, cesium chloride, many structures are there. Crystal structure prediction, we can use this kind of machine learning approach, algorithms, right? Uh, uh, so using that method, this is called one algorithm method called SVM, support vector machine. It can detect a new compound, and that will tell you with the help of already existing data set. 706 AB compounds are trained in a machine learning approach or algorithm approach. Then if you give a or unknown compound, an unknown compound, that will tell you what kind of structure it is. So, and also the results also very good comparatively with the human results, right? So you can see the chart. This is a crystal space determination and number of experiments. So generally, humans are uh, uh, so generally we made many mistakes, right, during the any synthesis or analysis part. But machines are very good in analyzing the data, right? That's a key point in it. And not only that, so if you want to design a structure of material, right, uh, you can use it. So this is kind of NSMP, that is a mobile packing algorithm. Um, it will tell you 12 microstructures, right? So you can see sphere type or rod shape or with combination of two different shapes, right? And different material combination or different metal combination, metal non-metal combination is all possible with this kind of already pre-trained algorithms. We can develop such a kind of material, microstructures. It is possible, and also we can simplify the synthesis route, right? You can see here. So if you feed the data like what are the solvent you are going to use for nanomaterial synthesis, temperature, time, and precursor type, precursor ratio, you can give it as an input for machine learning algorithm, and that will tell you at uh, output, right? So what kind of condition it is suitable for this kind of nanomaterial preparation. So right, so with this predetermined or pre datas, right? So it's already developed datas. We can feed the machine, and that machine will tell you, or algorithm will tell you, what kind of uh, condition is suitable for nanomaterial synthesis. So this is one example. So it is already reported in a paper, carbon dot preparation using this ML approach, machine learning approach. Okay, this is a nanomaterial synthesis and based. Then next type is chemometrics. Like so, we are getting different data, right? When we do some experiments, we are getting FTR data, Raman data, visible and UV visible data. So from that data, we can extract the information, right? So that kind of area of machine learning based approach is called chemometrics. And not only that, we are getting many SEM image, TEM image, right? So using that data, we can using some deep learning approach, and we can simplify the data. I will show you some examples. So this is the adulteration detection one, algorithm based detection. If our milk contains some adulteration like urea or whatever, some different kinds of adulteration, so it will sense and that will give you data, right? If you take IR, right? If you take a sample of milk and put it into IR, so what kind of adulteration is there, right? That will tell you. Using that data, XY data, you can create a data set, right? That is called so it's a huge data set, and using that different algorithms like PCA, PLSR, it's a principal list. There are different algorithms that is already it is there, right? So PCA, PLSR, the many type of algorithms are, as we discussed before. Many algorithms are there. If you feed the data, it will tell you, group the data into. So you can see this one. So here it's a blue color, it's a milk, or red color, or adulterant. So it simplify the data. So whatever the data, huge set of data we are given, it will easily uh, simplify the data, right? And it will reduce our time to analyze the data. And there are many are there adulteration detection, so huge set of area. So how it detects, like our human brain. So generally, if you feel some smell or coffee smell, then that signal is converted into processing, and that processing is converted in our brain, right? That neurons are converting, and that will tell you, okay, so this kind of smell, it is nothing but coffee, right? Same process, it is applied to machine learning approach. So again, it's called a neural network system is there. So it will tell you the output signals. And there are many examples are there with the help of nanomaterials and the nanomaterials and sensors and machine learning approach. Nowadays, there these kind of combinations are used in many um, medical fields. Like you can easily detect a CVD, right, cardiovascular disease, with this kind of three combinations: machine learning and sensors and nanomaterials, right? So nanomaterials, it sense or what kind of analyte is there, and that data is converted into machine learning. That machine learning predict and tell you that patient is he's in the stage, right? So that will tell you. So these are the different um, algorithms it is used for CVD, that is cardiovascular disease, for diagnosis, cardiovascular diagnosis. Not only that, we will see volatile organic compounds. Then again, it's another area you can see. So if some data is there, that data will split into acetone, IPA, ethanol. The data are easily grouped. So you can give a huge number set of data that will easily grouped into a different shape. The next one is image analysis. That previous so one scientist, they have given a beautiful talk on it, image processing, right? Again, it's used in medical purpose. So we pre-train the machine with this kind of images, right? So like this shape அப்படின்னா it's a cat அப்படிங்கிறது it's already pre-trained with the images. From that, if you give our unknown image, that will tell you and compare that unknown image are compared with the known images and tell you, okay, this is the cat image, or this is the horse image or dog image, whatever. So it's all pre-trained one. So same thing we can apply it for medical purpose. So if you take many MRI or CT scan images, so that data are considered as images, and you can create a huge data with that. So one person is affecting this kind of neural disease, or some affecting some brain blockage. So that will be indicated in the images. Okay, so this kind of image structure shows that person is affected this kind of disease or this kind of blockage. So when you feed unknown MRI image, that will map with this kind of algorithm and tell you the final result. So it's a very easy, right? And time very within a short time you can get the result. So same thing for data analysis in many disease. They are nowadays they are using it. Different algorithms they are using it. And you can see one more example, TEM image, right? Image processing. If you feed many TEM image or SEM image, it will analyze and it will create a data set. And if you feed our unknown data, right, unknown SEM image or TEM image, it is mapped with it and tell you how many spherical particles are there, how many square particles are there, skew particles are there, right? Size, shape, structure, we can predict with this kind of ML approach. And healthcare monitoring, yes, it is used. It's a combination of nanomaterials, sensor, and machine learning. Nowadays they are using it. I hope you know that one famous example is our smartwatch. If you see our smartwatch, it's consisting of 20 types of sensors, right? So all these sensors in somewhere they are using nanomaterials, right? So whatever may be the your sensor based material, so somewhere some point the nanomaterials must be there, because it is light in weight. There are many advantages, right, for nanomaterials, light in weight, and different property, chemical, physical property. Okay, these are the set of sensors which is there in our normal smartwatch. And so nowadays they are detection and monitoring of disease, right? So this is another area of research. So generally we prick the blood and analyze it for glucose. Instead of that, so nowadays they are using non-invasive methods for uh, monitoring our glucose level, right? Non-invasive methods like glass, tear glass, and skin, sweat. With the help of that liquids or some uh, okay, serum or whatever, so we can easily find this kind of disease, and time to time we can monitor. So these are the uh, combination of materials it is there in our sensor, like silver nanowire, CNT. Many are there, because these kind of sensors required lightweight material and also flexible in nature. So we can go for this kind of nano material based sensors, and flexible type sensors are there, wearable sensing electrodes. And you can see this is a set of flexible sensors containing materials like copper, gold, titanium. It is there. Even CNT are there, polymer materials are there. So that's because of the beautiful properties of this kind of nanomaterials. You can couple it with this kind of nanomaterial combination, sensor, and machine learning approach. This is already it's a developed product. You can easily uh, sense our blood glucose level with the help of blow meter, right? You can breath analyzer. If you just blow it, it will tell you how much glucose is there in our blood. So then not only that, even for cancer patient also, it can tell you whether the person is affected, what kind of cancer it is, right? Even ppb level of analyte it can detect, and that algorithm will tell you what kind of limit for a person is having cancer, so biomarkers, right? And finally it will tell you what kind of stage they are for cancer. It is already developed by Zhejiang University. It is there in the report. And not only the smartwatch, wearable sensor, smartwatch, it's another area. A smartwatch, using that a smartwatch, we can predict what kind of uh, the person is having the health issues. It's a time to time we can monitor. You just simply blow our breath and we can sense our disease or what kind of stage it is. So again, it's a wearable sensor market is there. Again, they are using basically they are using some nanomaterials and sensor approach and machine learning combination algorithms are there. So these are the key players: Google, Facebook, Amazon, Apple, right? Okay, so finally, some chatbot. Again, some useful chatbots are there. We can simply chat with that, and we can come to know that what kind of stay or what kind of um, health condition we are having, right? This is a freely available chatbot. Time to time, we can check it. And finally, this is acknowledgement and thank you for your patience. Um, and last one. Yes, yes, last one. Just see that. Okay, so fine. So the thing is, we can use that AI or machine learning, but we are the master, right? So finally, we can use them, right? We can get the help from them, but we are the master, right? Okay, thank you for your patience. If you have any questions, you can.
Thank you, sir. The session was truly enlightening. The session is open for discussion now. Participants, do you have any questions? Participants, do you have any questions? Participants, do you have any questions?
Yes, Kannan Venkatramani, he's posted the question: which AI tool will be highly reliable for material characterization, and which AI tool highly reliable nanomaterial characterization? Yes, sir. Actually, it's a nice question, sir. That depends, sir. Actually, generally, a nanomaterial characterization, it's a huge area, right? As I said before, so depends on the what kind of data you are having. Uh, FTIR data, UV data, TEM. So depends on the data, right? So you can choose uh, different algorithms. So if you want to split the data or if you want to group the data, you can go for one kind of algorithms. So PCA, PLSR, SVM. So there's a huge set of data are there. Uh, you can use it based on your applications or based on your need. I hope I answered your question.
Thank you, sir. Any other participants? Do you have any queries? Participants are requested to fill the feedback form, which is posted in the chat box. The feedback form will not be forwarded in WhatsApp group, so participants are requested to fill it here. Now, I call upon Ms. Gunachitra, Assistant Professor, Department of Physics, to deliver a vote of thanks. Sir,
Yes, madam. Sorry, so
sir,
disconnected actually.
one more question in the chat box, sir.
Can we able to find a particle? So in green synthesis, can we able to find particular compound which reduce the metal to find particular compound to find a particular compound which reduce the metal? Okay. Fine. It's a again a good question. So generally in green synthesis, so we all know that our plant source are containing huge set of flavonoids, alkaloids, and so many are there, right? So once we find it is in the different ratio also. So if we find what kind of or what is the quantity of alkaloids or flavonoids high, we can easily you can easily find what kind of compound which reduce the metal to metal nanoparticles, because we are not using selectively that chemical compound or chemical molecule. So alkaloids, flavonoids, it's a huge set of combinations are there in a plant extract. The thing is, if you know the exact combination of the plant extract, we can easily find what kind of compounds reduce the metals to metal nanoparticle. That also depends on the what kind of metals we are choosing. Let's take silver, it behaves differently. Silver to silver plus to silver 0, copper plus copper to copper, and whether we will going to prepare a zinc oxide material or a combination of metal oxides. So that all depends. Is it okay, sir?
Thank you, sir. Participants are requested to on your cameras for a photo session. All the participants are requested to on your cameras for the photo session. Participants are requested to fill the feedback form in the chat box. Now, I call upon Ms. Gunachitra, Assistant Professor, Department of Physics, to deliver a vote of thanks.
Thank you, Dr. P. Pachamuthu, sir, for sharing your valuable insights and research with us today. Your talk provided us in the, with in-depth understanding and fresh perspectives on the convergence of nano engineering and AI, which will inspire us all in our future endeavors. The practical examples and thought-provoking ideas you presented have left a lasting impression on everyone present here. Sincere thanks to our organizing committee and all participants for making this day a great success. Your support and enthusiasm are deeply appreciated. Thank you, sir.
Thank you, sir. Thank you, everyone. We can end your session today.
Thank you, participants. Thank you all.
Thank you, sir.
Thank you, sir. Thank you, sir.